Okay, lesson 11.4. So this is on two-way tables, which are actually pretty cool. They're really fun logic puzzles, and if you are someone who likes those things, you'll often see these show up as like puzzlers to stump you. But let's just talk about how they apply to some data collection. So these are some core concepts. We're not really going to discuss these in this lesson, but if you have questions on it, you can take a look at the book. They're not going to be part of the homework though that I'm assigning. We're just going to go over the overview of what a two-way table is. So if we look below here at examples 1 and 2 in these practice problems, these are what two-way tables look like. So there are a couple of components of them. There's going to be, what it does is it takes one set of data that has two different categories and it arranges it all together to show us the breakdown. So this is one category, attending college, and this is another category, the gender, person. Now within each of these categories, there's a subset. Either the person did or did not attend college, and then either the person is a male or they are a female. Okay, so those represent the categories. Now within those, we have or a subset of those, we have these data collection areas here. Okay, these are called, each of those 4 blocks are called our joint frequencies. So let's break down that term so that it doesn't sound like something we have to memorize, but something that makes sense. A frequency, if you remember back to histograms, is something where we take a table. Histogram is where it's used most often. We would make a table and we would say, all right, in this category, and we would take a tally, right? Things like that. So these are our frequencies. And it doesn't even have to be with intervals. It could be like if we're taking everyone's favorite color. We have people that like red, blue, yellow, and we would say 1 person liked red, 2 people liked blue, 4 people liked yellow, something like that. These here represent our frequencies. It's just how often it shows up, how frequent it is. Okay, so that should make sense. Now the next word there, if I clear all this, the next word says joint. So joint, if you think about a joint, it's whenever like your elbow joint or your knee joint somewhere in your body, it's something that where 2 things come together. So these are joint frequencies because this is, like if I look at the 98, that means that there were 98 students who were male that said they attend college. That's how you would read that. There were 132 students in this survey, maybe not even students, 132 male people that said they did not attend college. We would say for this joint frequency, there were 120 females that attend college, and then there were 88 females in this survey that did not attend college. So we can see if we look at all of those numbers that based on this data collection, which we don't know the background or anything about what they were asking or where they were asking it, we just know that they found that there were, of the male and female people that they interviewed, more males did not go to college or did not attend college, whereas more females did. Okay, and then you can add them up and figure out where the same number of people counted and a lot of different pieces of information. So just for our sake, we want to understand there's categories, joint frequencies. Okay, let's talk about the joint frequencies in this second example. So if we look here, our 2 categories, I'll reset just so there's more room. Our 2 categories here, are people that own a car. They either do or they don't, the yes and the no. And then again, male and female for our gender breakdown. Okay, so those are our 2 categories and then the options that come from those. And then from there, let's analyze what each of these joint frequencies mean. So 54 people own a car that are male. 136 of the males that were interviewed did not own a car. 45 of the people that were interviewed were female, and they said they did own a car. And 137 of all of the people that were interviewed said they were female and they did not own a car. So there were 137 females that did not own a car in this particular survey. Okay, so these are called joint frequencies. Now, if we look back at the directions though, which I was just kind of going rogue there, it says interpret the marginal frequencies. So let's talk about what a margin is. Think about a piece of paper. Okay, and then there's this sidebar, and there's these 3 circles, right? And then you're taught to write in this portion. You're not supposed to write in the margin. This is the no area. So the margin is like the extra, right? So here's what a margin a marginal frequency is. We're going to extend this down. We're going to add these two numbers up. So 98 plus 120, and we're going to put what that equals, which is 218. We're going to extend this column here down. We're going to add 132 plus 88, 220. And we're also going to do this on the right side here. We're going to extend this over. So I'm going to add 98 and 132. And when I do that, I get 230. And then I'm going to extend this second one over, 120 plus 88, and I'm going to get 208. Okay? Now, what the cool thing is if I go ahead and add 230 plus 208, I get an answer of 438. And then if I were to go across as well, 218 plus 220, I get 438. So this bottom right block is always going to represent the total number of people that were interviewed if we're talking about a survey. These are called marginal frequencies. Notice how they're like off the side of that table. They're in the margin. So they're marginal frequencies. So what marginal frequencies tell us, because the directions said find and interpret them, is the marginal frequencies help us understand, well, if I look across 230, that means there were 230 men that were interviewed total. And then I can say, well, of that 230, 98 attend college, 132 don't. If I look at the female total count, there were 208 total females surveyed. Of those, 120 attend college, 88 don't. And then if I go vertically, of the people interviewed, there were 218 that do attend college. And within here, it tells me the specific breakdown of how many of them were men and how many were female. In this column here, 220 total people said that they do not attend college. And then I see the breakdown of male versus female as well. So if I look at my numbers, I can make some interpretations. There is about an equal number of people, I keep saying students, of people that either attend college or don't attend college. So they're only off by 2. So wherever it was that they were pulling this data, it's a pretty even split. In terms of male and female breakdown, it seems like they were a little more heavily weighted towards the male end, but not by much. You know, there's not that big of a gap there. So, so that's how we can interpret that. Now let's take a look at this number 2. They want us to go ahead and interpret the marginal frequencies. So the first thing I have to do is draw in my marginal frequencies and figure out what those are. So I'm actually just going to extend this all together like this. Okay, and I'm going to add straight down. So 54 plus 45, and I get an answer of 99. We'll interpret them in a second. 136 plus 137, adding straight down is 273. If I add straight across, 54 plus 136, I get 190. And if I add straight across here, 45 plus 137, I get 182. Now if I add up 190 and 182, my total is 372. If I add up 99 and 273, my answer is 372. So my total is the same for both. So I know I didn't have any addition calculation errors. Now let's interpret it. So we already said this is talking about people who own a car and whether they're male or female. So of the people interviewed, and I'm going to just point to them, there are 99 people total of the total of the 372 people that were interviewed. There are 99 total that own a car. There are 273 that do not own a car. Okay, then if I take a look at this marginal frequency here, there's 190 of the people interviewed that were male, 182 of them were female. So out of 372, there's about almost an even breakdown of male versus female, but there is definitely not an even breakdown in terms of how many of them own a car. Okay, and then we would use that for whatever our purposes were, right? So whatever it was that can give us some insight. Like we said, right now they're collecting a lot of data. So maybe a two-way table here would say like, well, how does this match with that? And how is the breakdown male versus female? So they could do a lot of analysis based on it. Okay, all right, we're going to do a little bit more, and that is in creating our own, and then we're done. So it says here you conduct a survey that asks 85 students in your school whether they are in math club or chess club. 35 of the students are in math club and 20 of the students are also in chess club. 38 of the students are not in math club or chess club. Organize the results in a two-way table and include the marginal frequencies. This is where that logic puzzle kind of comes into play, and you can see why so, because that's pretty tricky in the phrasing. So we're just going to take it slowly. First, what I need to do is figure out my categories. So if I interview people, they're either in math club or chess club. So it has nothing to do with male or female. They don't tell us anything about that. So that's going to be my two clubs, my two categories too. My math club is going to be 1. And in that, they either are yes or they are not no. Now my other club is going to be chess club. And with that, they either are or they are not. All right, so let's fill all of that in. This is my table, and what I have in those blank spots will be my joint frequencies. Okay, so now I'm also actually going to extend it, and I'll even do that in a different color. I'm going to extend it and make my spot for my marginal frequencies, because based on the information they gave us, maybe something is going to be given to us that would fall in that margin. All right, let's take it piece by piece across the way. These, hopefully you find them a little bit fun. They can be a little perplexing, but if you just do it slowly, they're enjoyable. Or for me, they are at least. You conduct a survey that asks 85 students in your school whether they're in one of those clubs. So 85 students, think about, what does that mean? Not 85 said they're in math, or not 85 said they're in chess. You conduct a survey that asks 85 students. That means this is my total number of people that were asked. So I'm going to put 85 here. Okay? All right, now, so we check off all of that. Now, 35 of the students are in math club. Okay, 35 of the 85 students are in math club. So I look at math club. Of the people that said yes, I'm going to put a 35 here. And the reason I do that is because I don't know if 35 of them said yes to chess or if 35 said yes to no. I just know that there's a total of 35 that are also in math club. 35 of the total are in math club. So 35 said yes. So that's why that goes straight down there. Okay? All right, so let's block that out. 20 of those students are also in chess club. So 20 of this 35 are in chess clubs. So if I go backwards, I'm going to fill in one of these two sections. 20 of the 35 said yes to chess club, so I can put a 20 in here for chess, because this is my yes for chess and yes for math. So 20 are in both. All right, now 38 of the students are not in math club or chess club. So 38 of the total people asked said no to chess and no to math. Okay, so let's put a 38 here. They said no to math and no to chess. Okay, I'll get rid of those arrows, but that's why the 38 goes there. Now, that's everything they've given us. There's still a lot of gaps, but don't worry, we can fill in the blanks. So now I'm just going to go ahead to figure out this number here. I know that there were 20 that said yes to math. I don't know the number that said no to math, but they have to total 35. So if I kind of just use process like subtraction or thinking backwards, I can figure out that's going to be 15 students that said no to math. I'm sorry, no to chess, but yes to the math club. Yes, they're in this column. They said yes to math, but no to chess. Okay, and then if I keep going, what if I just go straight across here? So 15 and 38 is going to give me the total there. 15 plus 38 gives me a total of 53 students. Now this number means that there were 53 total students that said no to chess club. All right, what else can we fill in? How about this one right here? 35 plus something equals 85. 35 plus 50 equals 85. So we're going to put a 50 here. And then I can work backwards. Something plus 38 equals 50. And that's going to give me 12. And then lastly, 20 plus 12 gives me 32. Now to check and make sure we have it right, I'm going to go ahead and add these. 32 plus 53 is 85. It worked. 35 plus 80 plus 50 is 85. So we did it right, and then we could interpret these. We would say in the end, 32 total students are in chess club, 53 are not. 35 are in math, 50 are not, and then we can look at the joint to figure out the breakdown.